I've got this hair trimmer here that kinda doesn't work. It's plugged in, its green light is on. I tested the plug. It's got 4.5 volts coming through it from the charger. And when I switch on the machine, the blades barely move, if at all. If I take off the cutting blades, you can see the motor runs barely. It should be running, I don't know, 10 times faster than this, and it's very easy to stop it with a light finger force like so. So something is not working entirely well inside. I'm gonna take it apart. I don't see a single screw on this one, so we'll try to take it apart with a putty knife and see what happens, what lives inside, and why it's not working properly. And this is how everything looks like when they are taken apart into two halves. The two halves do not go back together. They are irreversibly taken apart. Then they don't look broken, but the two halves were designed very clever, that these cross pieces and these snap hooks, they shear off when the two halves are taken apart. It's clearly meant for a purpose that nothing be serviceable inside. Inside the unit, a single nickel cadmium, very old school AA battery has died years ago, and so I'll see if I can bypass it very simply. And all there is to this whole thing, it's got a single LED there and a circuit board that does possibly something else too. And when I switch it on, we've got the same lazy motor situation that barely spins there. So even if I put it together, it's only going to be held together with duct tape, zap strap, who knows what. The motor is also constructed in a way that it doesn't have screws in it. It's crimped together. You see that dimple there? That motor housing and the insides are crimped together. So you have to take it apart, you're gonna have to undo those crimpings. I don't know if I ever need to do it, but I will take it apart and we'll see why it's not spinning at the normal RPM that it used to. And the wires, other than a little hair and this and that, the wire seems to be intact and the non-moving parts. And I'll clean the switch out, see if that fixes it. I'll take out after the switch cleaning, I'll take out this battery, see if that helps the motor's RPM. So to touch and open the motor, that's going to be the last thing after the other two are cleaned or looked at. So we'll start with the switch there. Alright, I've taken the compressor. Let's see if we made any difference whatsoever. I blew out with the compressor all of the hairy bits from the switches. There you see the cardboard is behind it and underneath, so it's no longer fuzzy anywhere. Let's see if it amounted to anything. Nope, nothing whatsoever. Exactly the same RPM. I think this speed, if there's warp speed, then this is pathetic speed. Alright, so motor is functioning the same way. Alright, I'll keep looking. We've got a couple of measurements here. So in this configuration, when electricity flows through the plug, we have 4.2 volts being read between the two probes. So this is the socket into which that plug plugs into, and the socket inside is the positive terminal, the socket outside is the negative terminal, and the two of them, the metal surfaces are joined at the end, but you can see that the plates are separated by an insulating piece of cardboard or whatever. They're under the first piece of metal, but above the second piece of metal. And the first piece of metal comes up to the surface, to the circuit board, through this one pin over here. And thereabouts. Sorry guys. There. And the second pin, or the other part there, also pokes through the surface. It's probably this big blob there next to my finger. So let's measure and see what we get between the two of them. So when I check the voltage between these 2 points where the electrons come in, I'm only looking at 2.6 volts. Yeah, take a look over here at the instrument. I just make the picture sharp, and there it is, 2.659, 2.66. So now it's nothing, and now it's still 2 point. It's 4 point something for a sec, 4.5 there for a sec, and then it settles at 2.6. So it tells me that the electrons that initially started 4.5, they go somewhere. So next thing, here one last time. Yeah, you see, that's what happens. So I'm gonna try to take out this old dead nickel cadmium battery. Very straightforward, just solder it out, and say I'm gonna undo the soldering here at this point and here at the other end, just there and there, and see what happens. And here, let me show you what kind of difference it makes when the battery is out of the circuit, the dysfunctional battery. Just listen. Alright, so that motor is running back to its normal speed, maybe even it's a little too fast. And the voltages that I'm getting between this and this point here on the circuit, we are getting, we're getting 3.6 volts now. Still not 4.5, but it's 3.5. And when the motor is running at these 2 points, I'm getting 2.2 volts while the motor is in operation. So, well, I guess I'll just put everything back together and see if it stays together in the housing. The halves snap back together enough to avoid duct taping and elastic banding, even though all of these broken bits came out from inside when the gray halves and the black halves were pried apart. So, and of course the battery is out of the system. With the RPM that it's got, the green light is on. That's very nice. That's just as good as, just exactly the same speed as, no load speed as it was before. So I can conclude that it was this dying dead battery that was sapping the power, and there, that saved me another $60 and going to the store. And okay, now it needs to be plugged in all the time, but it still works. That's another 15 years out of it, I guess.